Let's talk more about this concept of vectors in C++. Now, vectors are a solution to built-in arrays, partially because you can't resize built-in arrays, right? So the first thing to note is that the goals of vectors is to make this a container that you can resize, right? And what that means is we can allocate a block of memory, and this thing could be holding 3 elements of whatever, 3 players, 3 integers, 3 something, right? And then at a later time, we could say, you know what, we want to add a 4th. And what it would do is it would say, okay, under the hood, you can now add 4. And we don't want any issues with that, right? This is really a convenience thing for us as programmers to be able to add more data into a container like this, right? Now, it's storing these things in a contiguous block of memory, which gives us a couple benefits. One is it means that it's fast to access all of the data within here, right? So it's fast random access. And it also means that under the hood, it will probably be using this new and delete operator, as well as using the idea of built-in arrays, right? So you allocate an array of size 3, you want to add another element in there, you delete that one, and then you allocate a new one of size 4, right? Now, some of the common functionalities that vectors have would be resizing them, obviously, right? Growing them, shrinking them, adding elements to them, and removing elements from them. So there's a couple specific things that we need to keep in mind within all of these sort of basic operations. So the first fundamental basic operation that we want to be able to support is the resize function. Now, all of our vectors, and this is really the most important thing here, is we want to be able to resize these things. And there's a couple things to keep in mind. If we have a vector that currently has space for 3 in it, and we want to resize it to have space for 4. Let's think about the process and able to do that, right? We have a block of memory allocated, and this is going to have data in it. 1, 2, 3. Let's just say it's holding integers 1, 2, and 3. Well, a couple things need to happen. The first is we need to resize this thing to something greater. Let's just assume it's 4 for now. The next thing is we need to copy all the data over, right? So we need to allocate a new block of memory that is larger. We need to then copy the data over, 1, 2, 3, right? And then we could finally go and remove the old block of memory that we originally had. So this resize function can be a little cumbersome. As an optimization, vectors have something called capacity. Now, the capacity of a vector is different than the size of a vector. Now, remember that the size of a vector would be how many elements are in the vector. So in this case, there'd be 3. The capacity of a vector is how many elements it could support before it needs to be resized. And let me give you an example of what I mean by this. Let's say I initially create a vector that supports 5 elements like this, right? Now, when I go and add a 6th element in, first thing I need to do is I'd say, well, I need to go and resize this thing, create a new block of memory. And this is going to be a really slow and inefficient function. I need to create a new block of memory. I have to transfer all the data over to the new block, right? And boom, here's my 6th element. And then you go to add another element in. Ah, man, I got to go through all that again. All right, well, now I need to resize this again at 1 more, right? I got to copy all this data over. This resize function becomes really slow. So instead, what vectors do under the hood is they reserve some amount of capacity, right? So these are some keywords here: capacity versus size, resizing a vector versus reserving space in a vector. These are all keywords that you'll need to know. When I go to reserve space for a vector, what I'll do is say, well, say you have a vector that has 5 elements in it, like this, and you go to add a 6th element. Well, as an optimization, you know what? I'm going to reserve space for 10, right? Or for 30, or for 1,000. The point is I'm going to reserve more space than you're looking for so that I don't have to do this cumbersome operation over and over and over again, right? So let's resize to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My last one's real small. Okay. I originally had 5. I had the values in here, 1, 2, 3, 4, 5. We go to resize, and then what I actually do under the hood is I'm going to ask for a full new block of memory that's double the size of what it previously was. So now my capacity here, my capacity is currently 10, right? My size is 5, right? If I'm adding one more element, my size would be 6, right? So here's the size, which is 6. That's how many elements you've actually added into this thing, right? I would copy all my data over 2, 3, 4, 5, 6. I'd add the new element into it. And now, for the next handful of operations, if you add more data, I don't have to do this resizing thing anymore, right? It's purely just an optimization to avoid this cumbersome task of transferring data over and allocating new space and removing the old space, right? We want to try and avoid that as an optimization here. So vectors have this idea of a capacity, right? They have the idea of the size, right? This will be a built-in array that's in the guts of the vector that's pointing to this memory location, right? Cool. What else do you know about vectors? Well, in addition to be able to resize, right, with this idea of capacity, typically we can specify in advance. If I know that there's going to be 6 elements that are going to be in here, when I declare this vector, I could request a capacity of 6 or request a capacity of 100, right? This is called reserving. So most vectors have a function called reserve. And what that does is it expands the capacity, not the size. I'm not adding anything more into it, but it expands the capacity so that I can add more things into it in the future without hitting this this terrible process of copying data over, right? Most vectors also support the operation of pushback, right? Push_back. Pushback is the name of the function to add a new piece of data on the end, right? It's essentially like an insert function where an insert might go into the middle. Pushback says, let's add this new element on the very end, right? So I'm going to push back the number 7 and push back the number 8, right? It's called pushback. A lot of vectors support an insert function. Insert typically takes 2 values. What's the value you want to insert? And then where do you want to insert it? And if you want to insert a value here at this position, well, one of the things that vectors need to do is, because it's using this contiguous block of memory, this insert function can actually be kind of slow. Think of what might need to happen if I go and insert a value here at the very beginning. Well, there's no room here for me to have a value at the very beginning. So really what would need to happen is I would have to shift every value down. Shift them all down, and then shift them all down until I free up space here, and then I can add a new value here at the very beginning. So I could set this one to 0, and then this would be 1, 2, 3, 4, 5, 6, right? So you can imagine that this operation of inserting a value of 0 at the very beginning of my vector would also probably be pretty slow. I have to copy all of the data. If I have 1,000,000 elements in my vector here, inserting something at the beginning is not just a single operation. It's actually 1,000,000 operations because I have to copy all this data over, right? So these are sort of the basic functions that vectors have: resize, reserve, pushback, insert. There's a couple other special case ones, but these are the guts of what contains a vector class.